This is Miss Humbert here, and today we're going to be talking about Unit 4 notes for us. We're going to be factoring when a is equal to 1. We're going to talk more about what that means in a second. But to start off with, I first want to just kind of take a little bit of a review of Unit 3. So I want to take a look at something we did in Unit 3, which was multiplying binomials. Now I've mentioned in class that sometimes what Unit 4 is going to be is basically undoing Unit 3. Okay, so when we multiply binomials, I typically use the box method. You can also use FOIL. So x times x is x squared. X times negative 2 is negative 2x. 1 times x is x. And 1 times negative 2 is negative 2. So we're going to write out all of those terms, combine our middle two terms, and we get x squared minus x minus 2. I want you guys to go ahead and try number 2 on your own. So again, you're just reviewing that multiplying of binomials. So during this unit, from now on, we're going to be talking about quadratics. So what is a quadratic? Well, a quadratic, first of all, takes the general form of ax squared plus b. One of the biggest coefficients is going to be that a coefficient. So if you notice, the title of this note sheet is factoring when a is equal to 1. So that means that we're factoring when that coefficient with the x squared is equal to 1. Okay, and the process that we're going to be using today is called factoring. Now this is one of the most basic, most important skills that you're going to learn in algebra, so it's really important that you get it down because you'll be using it in geometry, in algebra 2, and all the way through calculus. Okay, so when you have a squared term, we can't just solve for x like we would by dividing and multiplying and adding like we would when we're solving equations. So we have to do a different method, and that different method is called factoring. So first of all, you just want to check for a GCF. That is the most important. So I actually have 5 steps written on here, so you're going to have to change that up, okay? Just add a 5th one. So first you need to check for a greatest common factor. Factoring is a lot easier if you can pull out a greatest common factor first. Remember, we did that on the first note video of this unit. Next thing you want to do is set up your x, multiplying a times c, and then adding to b. Now because our a is equal to 1, it's really just going to be c on the top of our x. Then you're going to solve the x just like you did on the previous note sheet. But here's where it gets a little bit tricky. So we're going to rewrite that polynomial or that quadratic out, splitting up the b terms. Now that might not make sense right now. It probably makes more sense when we start talking about these quadratics. And then you're going to factor by grouping. So factoring, it takes factoring the GCF and factoring by grouping, the first 2 things we did this unit, and uses it. So you do need to have those skills to move forward. Alright, so the biggest thing with this is you can only just take the c value when a is equal to 1. Okay? So let's take a look at what this is going to look like. So let's go ahead and set up our x. So we're setting up our x. Now normally we'd multiply a times c, but since a is equal to 1, it's just going to be 5. So we're multiplying to 5 and adding to 6. This is something you've done before. Okay, so to multiply to 5, you have 5 and 1. So to add to 6, we're going to do 5 and 1. So completing the x shouldn't be that difficult anymore. Now here's the new part. So what I'm going to do is I'm going to keep my squared term the same. Then I'm going to take this middle term. And instead of writing 6x, I'm going to write that as 5x plus 1x plus 5. So now if you notice, I have 2 terms. Or 4 terms, I'm sorry, okay? So I have 4 terms. 5x plus 1x is still 6x. So it really is the same equation, I'm just splitting it up. Well, because I have 4 terms, I can very easily factor by grouping. So between x and 5x, I can divide out an x, dividing each term by x, and then I'm left with x plus 5. Again, this is just factoring by grouping. So I took out the GCF of the first group. Taking a look at the second group, between 1x and 5, there is no GCF. So I'm just going to take out a 1, just to remind myself that that 1 is there. And then I'm left with x plus 5. So I notice now that my leftovers are matching. And then once I get rid of those, I'm going to write what's left after that, which is x plus 1. So if you notice, this is now written as 2 binomials being multiplied together. That's factoring. Okay, so we did this all kind of piece by piece by piece. Now we're tying it all together. Let's take a look at number 4. So for number 4, we're going to be multiplying to 16 and adding to negative 10. So since my product is positive and my sum is negative, I need to have 2 negative factors. Well, let's take a look at things that multiply to 16. We have 1 and 16, 2 and 8, 4 and 4. So we have the same sign. So the two that add to 10 are -2 and -8. So those are going to be the ones that I use. So now that I've done that, I'm going to take and I'm going to split up this -10x. So I first have x squared. Now instead of writing -10x, instead of writing it, Miss Humbert, there we go, I'm going to write -2x minus 8x plus 16. Okay, now from here I can go about factoring by grouping once I have 4 terms. So I make my first group and my second group. Between x squared and 2x, I can take out an x, and then I'm left with x minus 2. Now taking a look at my second group, notice that there's a negative sign in the middle. So that means I need to take out a negative GCF. So between 8 and 16, I can take out an 8, and I'm actually dividing each term by a -8. So when I do that, dividing each term by a -8, then I'm left with x minus 2, also in the parentheses. So I check and my leftovers are matching, so I can go ahead and pull those out. And once I factor those out, I'm going to write what's left after that, which is x minus 8. So this right here is your fully factored form for number 4. Let's take a look at number 5. So for number 5, we're going to be multiplying to a -18. Again, we can do that because our a is equal to 1, and we're multiplying to a -7. So we need to have a positive and a negative factor because our sum is, or our product is negative. So for 18, I have 1 and a -18, -1 and 18. Some of you might be able to see what it's going to be without doing all of this, and that's fine. But if you can't, this is a great way to go through all of the factors and make sure you have them. So all I did was write out all the factors of 18, switching the negative signs. So I noticed that 2 and -9 are going to give me that -7. So now I'm going to rewrite out the equation, and I'm going to split that term up. So I'm going to have x squared plus 2x minus 9x minus 18. So again, notice that if you were to add those two together, it would still be -7. So I haven't really changed the quadratic yet. I've just used the x to help me figure out how I can split those terms up. So now I'm going to factor by grouping. Out of my first group, between x squared and 2x, I can take out an x, and then I'm left with x plus 2. Between -9 and -18, I can take out a -9, so all of those signs are going to change, and I'm left with x plus 2. So then I notice that my leftovers are matching, so I'm going to factor those out, and then I'm going to write what's left over after that, which is x minus 9. Now, if you're unsure if you did that correctly, you can always go back and use the box method to multiply into the box, and make sure that once you do that, you get this quadratic right here. So I'm going to go ahead and have you guys try number 6 on your own. Alright, so this leaves our next question. Are all quadratics factorable? In fact, no, they're not. So there are actually some quadratics that we can't solve using factoring. Okay, if a quadratic is not factorable, then we can't get the x to work. If the x works, it should be factorable. Instead of writing an answer, we're going to write not factorable or NF. So let's go ahead and take a look at some of these. So starting with number 7, we are going to multiply to 2 and add to 2. Okay, so let's take a look at the products of 2. So I have 1 and 2. I notice that I have a positive product and a positive sum, so both my signs are positive. So somehow I need to take 1 and 2 and add that to 2. Well, that's never going to happen. So this is NF, not factorable. Factorable. Let's take a look at number 8. So for number 8 now, we're multiplying to 2 and adding to 3. I want you to see if you guys can figure that one out on your own. Identify if it's factorable or not. If it is factorable, please factor it. Same for number 9. I want you guys to try that one on your own. You're multiplying to a -2 and adding to 1. So you're going to have a positive and a negative sign since our product is negative. So I want you to go through and multiply that out. If it's factorable, factor it. If it's not, say NF. Next, let's take a look at number 10. So for number 10, we're multiplying to 9 and adding to 3. So things that multiply 9, 1 and 9, 3 and 3. Well, my sum and my product are positive, so I have two positive 9s. There's no way I can take 1 and 9 and 3 and 3 and get them to add to 9. So this one is not factorable, NF. So that concludes your note video today. Make sure you go on to Schoology to take that quiz, and we'll talk about this more tomorrow. Thanks for listening.